Welcome to Agentic AI World, your daily interview prep for AI and ML engineering roles. I'm your host, and today we're diving into episode 23, AI Model Deployment Strategies, how to ship AI to production like a senior engineer. If you've ever been asked in an interview, how would you deploy this model, and froze, this episode is for you. Let's break it down. Section 1. Why deployment is a first-class problem. Most AI engineers are great at training models. Far fewer are great at deploying them. That's actually your competitive edge. Interviewers at top companies, think Google, Meta, Stripe, want engineers who can think end-to-end. Training a model is only 10% of the real work. Getting it to production reliably, safely, and cost-effectively, that's the other 90%. The deployment question usually sounds like this. How would you deploy a model that handles 10 million requests per day? Or, walk me through your deployment architecture for a real-time recommendation system. Here's how you answer it like a pro. Section 2. The 3 deployment patterns you must know. Pattern 1. Batch inference. This is the simplest and most overlooked pattern. You run inference on a large dataset offline, not in real time. When do you use it? When users don't need instant results. Think overnight fraud reports, weekly churn predictions, daily content recommendations. The architecture is straightforward. You have a data pipeline that feeds a batch job, could be a Spark job, a cron-triggered Lambda, or an Airflow DAG. The model runs inference on the full batch, writes results to a database or object store, and your application reads from there. Why it matters. Batch inference is cheap, easy to scale, and easy to debug. Always mention it as an option before jumping to real-time. Pattern 2. Online inference with a model server. This is what most people think of when they say deploy a model. You expose the model as an API endpoint. The standard stack here. Wrap your model in a fast API or Flask app, containerize it with Docker, deploy it on Kubernetes or a managed service like AWS SageMaker, Vertex AI, or Azure ML. Key components to mention in an interview. 1. The model server itself. Tools like TorchServe, Triton Inference Server, or RayServe handle batching requests, GPU utilization, and multi-model serving. 2. Horizontal scaling. You need auto-scaling based on request volume. Mention HPA, Horizontal Pod Autoscaler, in Kubernetes or auto-scaling groups in cloud environments. 3. Load balancing. Requests get distributed across multiple model replicas. 4. Caching. If many users request the same input, think popular search queries. Cache the output in Redis or Memcached. This can cut inference costs by 40 to 60%. Pattern 3. Streaming inference. This is for real-time pipelines. Think fraud detection, live recommendations, or streaming analytics. Here the model integrates with a streaming platform like Kafka or Kinesis. Events flow in, the model processes them as they arrive, and predictions flow out to downstream consumers. This is more complex, but shows real depth in an interview. Section 3. The 3 questions every interviewer is testing. When you get a deployment question, the interviewer is actually testing 3 things. First, do you understand latency requirements? Know the difference between P50, P95, and P99 latency. A senior engineer always asks, what's the SLA? Is 500 milliseconds acceptable, or do we need sub-50 ms? Second, do you think about cost? GPUs are expensive. Mention model quantization, reducing precision from float 32 to N8 to cut inference costs by up to 4x with minimal accuracy loss. Mention model distillation if appropriate. Third, do you think about reliability? What happens when the model server goes down? You need health checks, circuit breakers, fallback logic. If your AI recommendation system fails, does your app fall back to a rules-based system or show nothing? Section 4. The deployment checklist. Here's a quick checklist you can mentally walk through in any interview. Containerization. Is the model in Docker? Is the image reproducible? Versioning. Are you using a model registry like MLflow or weights and biases to track model versions? Monitoring. Do you have drift detection? Are you monitoring prediction distributions in production? Tools like Evidently AI or RI's Phoenix are great to mention. Rollout strategy. Are you doing a full cutover or a Canary deployment? A shadow deployment? Blue-green? Always mention Canary. Deploy to 5% of traffic first. Validate metrics, then scale up. Rollback plan. If the new model degrades metrics, how fast can you roll back? This is a huge green flag in interviews. Section 5. The answer structure that impresses interviewers. When you get a deployment question, structure your answer like this. Step 1. Clarify requirements. What's the expected QPS? What's the latency SLA? Is this batch or real-time? Step 2. Propose a pattern. Given those requirements, I'd go with online inference using a model server. Step 3. Sketch the architecture. Walk through the key components: client, load balancer, model server, database, monitoring. Step 4. Address the hard parts. The tricky bits are cold start latency, GPU cost optimization, and handling model drift over time. Here's how I'd tackle each. Step 5. Mention trade-offs. The downside of this approach is X. An alternative would be Y, which trades off latency for cost. That 5-step structure alone will put you ahead of 80% of candidates. Section 6. Quick-fire concepts to know. Model quantization, reducing numerical precision to speed up inference and reduce memory. ONNX, Open Neural Network Exchange, a format that lets you export models from any framework and run them on optimized runtimes. Triton Inference Server, NVIDIA's high-performance serving platform, supports batching, multiple backends, GPU acceleration. Shadow mode deployment, running the new model in parallel with the old one, logging its predictions, but not serving them to users. Great for validation before full rollout. Feature stores, centralized repositories for features used in training and serving, ensuring consistency between the two. Feast and Tecton are the common ones. Wrapping up, to nail deployment questions in your next AI interview, remember, know the 3 patterns: batch, online, streaming. Pick the right one based on requirements. Think about latency, cost, and reliability, not just accuracy. Use the 5-step answer structure to show your thinking, not just your knowledge. That's episode 23 of Agentic AI World. Drop a comment with any deployment challenges you've faced. I'd love to cover real-world scenarios in upcoming episodes. If this was useful, subscribe and hit the bell. New episodes drop daily, covering everything you need to land your next AI or ML engineering role. See you in episode 24.